So this is A2Pure Maths. This is our second video then on modulus. So we're looking at the modulus sign and modulus inequalities. So the modulus of x means the magnitude or modulus of x, i.e. we're only interested in the size of x and then can disregard the sign. The modulus of -7 is 7, -2 is 2, and 3 is 3. And we're asked then to solve the inequality. The modulus of x minus 2 is less than 3. There's a couple of different ways of doing this one. So we'll kind of go for method 1 here. And the trick to this then is to set it up like this. Because this can be a positive or negative effectively, we want to go with -3 less than x minus 2 is less than 3. The way we would have solved this at GCSE level is just to separate them out. So I'm going to do the same thing. -3 is less than x minus 2, or x minus 2 is less than 3. Solving this then, we would add 2 to both sides. So -1 is less than x, and then here x is less than 5. So my solution in this particular case is x is going to be in between -1 and 5. We can also square both sides, by the way. That'll work as well. That gives us our different options then for that. Another option is to plot the graphs of the modulus of x is -2 and y is 3 on the one diagram. So how's that going to look? We'll just practice this. So this is a gradient of 1 and a y-intercept of -2. So that would have crossed here and would have crossed then at 2. And see if we can work out some sort of graph then from here. This is maybe easier said than done. So that would have been a dotted line there. And we have our graph heading up this way here. And the other graph, the other half of the same graph, is going to head this way. What about the line y equals 3? So that's going to be a horizontal line. Crossing there at 3. So if that was 2, the gradient's 1, that's going to cross at 2. So 3 is going to be round about here. And that's the line then, y equals 3. So that's y equals 3, that's y equals the modulus of x minus 2. And that's a case of trying to work out then where those two lines cross each other. It's straightforward enough really. I mean, you can use your common sense. That's currently at 2. So go as high as 3, we're going to go across 3 up 3. So that would be the point 5, 3. And then this would be the point -1, 3. We can solve it. I think we're going to solve it below then by squaring both sides, but you can do it that way. And we're asked for whenever this is less than this. So where is this graph lower than this graph? That's obviously in between -1 and 5, which is what we had up here then for our answer. But to find the point of intersection, we can set it up this way. We can go x, modulus of x minus 2 is 3. And if we square both sides, we would get then x minus 2 all squared is 3 squared. X squared minus 4x plus 4 is 9. Rearranging this quadratic, x squared minus 4x plus 5 is 0. And then x plus 5 and x, sorry, that's x minus 5 of course, sorry, plus 1 equals 0, and our two values then of intersection, x is -1 and x is 5, and that's then by squaring both sides. So our points of intersection then can solve then from there. As I said previously, where on the graph is this graph here lower than this graph here? And so by looking at the graph then it's between -1 and 5. Sorry, you can't see that there, in between -1 and 5. So hopefully that makes a little bit of sense. Let's take a wee look then at our next example. Solve for x. 2x minus 1 is less than or equal to a half. So let's go for method 1 then for this one. So what would we do? We would go 2x minus 1 and then less than or equal to minus a half here and then a half here. So if we take each bit separately, minus a half less than 2x minus 1, and then 2x minus 1 less than or equal to a half, and trying to solve this then. So what I'm going to do, I'm going to add 1 to both sides. I would have a half less than or equal to 2x, so a quarter less than or equal to x, and then I have 2x less than 1.5 once you add 1 to both sides, and I have x then less than or equal to 3/4. So our solution in this particular case is a quarter, so equal to x and 3/4. If I wanted to do this by doing the graph again, it would just be very similar to the last one. My graph of y equals 2x minus 1, so that crosses at minus 1, and I have a gradient then of 2, so it would go up reasonably steeply, but just for the sake of the diagram we won't go quite so steep. So that would be dotted there, and then the actual graph goes up like this. And it's the line then y equals a half, so we're reasonably low then along here. So that's the line of y equals a half. That's the line y equals the modulus of 2x minus 1. And to find our point of intersection, like the last time, we squared both sides. So we would have 2x minus 1 equals a half, squaring both sides. 2x minus 1 squared equals a half squared. Multiplying this out gives me 4x squared minus 4x plus 1. And squaring a half, then we get a quarter. Taking away a quarter from both sides gives me 4x squared minus 4x minus 3/4 equals 0. I don't like the quarter sitting in there, so I'd be multiplying through by 4. 16x squared minus 16x minus 3 equals 0. I think that's plus 3 actually, is it? It is. That's plus 3/4, and that's a plus 3, sorry about that. And then that factorizes, giving me 4x minus 3, and then 4x minus 1 equals 0. That gives me 4x is 3, so x is 3/4, and 4x is 1, obviously then x is a quarter, and those are our two values in our points of intersection. So where on the graph is this graph here? What do we ask for? Less than this graph here. Of course it's in between those 2 points, so from the graph x is in between a quarter and 3/4, which is what we're looking for. Finally then, example 3. Solve for x. 2 minus 3x is greater than or equal to a quarter. So we have 2 minus 3x is greater than or equal to 4, or equal to minus 4, and we set it like that. Minus 4 greater than or equal to 2 minus 3x, and then 2 minus 3x greater than or equal to 4. Rearranging and solving this, we get x greater than or equal to 2. I'll leave that for you guys to solve. And then for the next one, this one, x is less than or equal to minus 2/3. So this is two different regions here, so we keep them separately. So we will have x is less than minus 2/3, and x is greater than or equal to 2. So how do those graphs look? So that's my 2 minus 3x. I believe I drew one of those earlier in our previous video. So down here and up here, that I think is my point 1. That's my point 2, and then it's a line y equals 4. So that's a little bit higher up again along here. So I need to work out where you can see on the screen here. So I have that, and to find my points of intersection, as we did with the last time, we're going to square both sides. We have 2 minus 3x equals 4. 2 minus 3x all squared equals 4 squared. 4 take away 12x plus 9x squared equals 16. If I rearrange that, I get a 9x squared minus 12x minus 12 equals 0. Everything there divides by 3, so it would give me 3x squared minus 4x minus 4 equals 0. 3x plus 2 in one bracket, x minus 3 in another bracket, and giving me my two values then is x equals minus 2/3. Sorry, that should be a 2 as well, shouldn't it? Excuse me. Let's just check that's right. Yeah, that's minus 6 and that's 2. Or then x equals 2. And again, by looking at the graph, we want to know. So look at this, look what it's asked for, where this graph here is greater than this graph here. So where's this graph here greater than this graph here? It's from here out and from here out. So from the graph, we will have x is less than minus 2/3, or x is greater than or equal to 2.